So, what can we calculate from a position time graph? A position time graph gives us information about displacement between any two instants. Second, it gives us average velocity between any two instants, and it gives us instantaneous velocity at any instant also. Let us now take up these 3 points in detail. How to calculate the displacement between any two instants? So, here is a sample xt graph. The position versus time graph is a curve as shown between A and B. Now, the time instants are t1 and t2 respectively. Now, how to find the displacement? At time t1, find the position x1. At time t2, find the position x2. So, we have got x1 and x2. Now, in order to find out the displacement, we write x2 minus x1. So, the displacement between these two instants is x2 minus x1. Thus, we can write delta x is equal to x2 minus x1. This is how we calculate the displacement, and it applies even if it is a straight line or maybe it is a curve, does not matter. Then, how do we calculate the average velocity? Again, the same graph is used here, the same straight line or rather same curve is used, and the time instants are t1 and t2 respectively. At t1 the position is x1, at t2 the position is x2. So, the steps are here. First of all, find the value of x1 at t1 and then x2 at t2. We have already obtained what that displacement is. Displacement is x2 minus x1 divided by t2 minus t1. Now, we divide this displacement by the time of the journey, and that gives us the average velocity. So, you can write average velocity is equal to displacement divided by time taken. What is the displacement? X2 minus x1. Was the time taken? T2 minus T1. Thus, the average velocity is delta x by delta t, which is nothing but x2 minus x1 divided by t2 minus t1. So, this is how you calculate the average velocity between two instants. Then, the third part, how to calculate the instantaneous velocity at an instant. Now, as a generic example, we are considering a curve here. So, this represents position versus time graph. How to find the instantaneous velocity? The steps are here. Now, let us assume that we have to find the average velocity, rather instantaneous velocity at time t1. So, now corresponding to that time t1, this is the point. So, we find the point on the graph. Then at that particular point, we draw the tangent. The tangent is drawn at that point. Observe that the tangent cuts the time axis at an angle theta. The angle theta made by the tangent with the horizontal, that is the time axis, is to be found out. And clearly this is theta, and instantaneous velocity v is equal to tan theta, because you know that v is equal to slope and slope is equal to tan theta. And remember, this is applicable even for a straight line. For example, if I consider an xt graph in the form of a straight line, observe that at this instant t1, this is the slope. So, slope is nothing but tan theta, and clearly slope is equal to tan theta, therefore, v is equal to tan theta.